like x squared, let's say on the interval 0, 2. Can anyone refresh our memory on what type of function is that?
Quadratic.
Excellent. It's the simplest possible quadratic function. It has the vertex at the origin. When x is 0, y is 0. When x is 1, how much is y?
1.
Perfect. And when x is 2, how much is y?
4.
Excellent. So here's the graph. This is the graph. Notice that this is given to us. It's a fixed interval. So we're talking about this. Nothing to the side, nothing above, nothing. Just this. We're asked to find the area under the graph. We cannot really find it at this point. We will very soon. Not the exact. Approximating it with 4 subintervals. Find the area, which we cannot really find, but I'll continue. Find the area under the graph, approximating it with 4 subintervals. Later, we will be able to find the exact. Later, we will find it exactly. But right now we don't have all the tools. Okay, so I'm going to take the graph from there because I'm trying to explain. So this is the interval 0, 1, and 2. They want us to use 4 subintervals. Okay, so I will divide the entire interval between 0 and 2. This is the interval between 0 and 2 right here. I will divide into 4 equal length subintervals. So this is definitely 0.5. This is definitely 1.5. And the graph is somewhere here. Okay? So what am I trying to do now is, with 4 subintervals, I'm trying to create rectangles that I know how to calculate area for. So what is the area of this rectangle? Base times height. Base times height. Okay. We have several possibilities. We have what is called, number 1, leftmost point. It will appear very clear in a minute. Number 2, rightmost point. And of course, midpoint. So we can approximate this area under the graph between the x-axis and the graph of x squared, clearly only between 0 and 2. We can approximate it using 4 subintervals. You can say, why 4? Why not 16? Why not 32? We will get to that in a minute. So for now, the question is asking us to use 4 subintervals and illustrate and find the area using the leftmost point. After that, one more time, the same area using the rightmost point, and the third time, the same area using the midpoint. Okay. So let's start with the leftmost point. So here's my graph. Again, I'm not going to graph it exact. I have 0, I have 0.5, I have 1, 1.5, and 2. And this is the area left 4. Leftmost point, 4 subintervals. So the leftmost point, the height at the leftmost point is 0. So here I have no area. the height at the leftmost point is here. So now this is the first rectangle. Here is the leftmost point for the next subinterval. So now this is the area. And the last one, here is the height for the leftmost point for the last piece, last subinterval, and I have this. So base times height plus base times height plus base times height plus base times height. 4 subintervals. The first one, base, 0.5. Notice that the base is 0.5 for all of them, so I'm going to pull it out. 0.5 times the height at 0 plus 0.5 times the height at 0.5 plus the base times the height. The base is here, f of 1, and plus the base, which is here, times the height, f of 1.5. We will calculate this area in a minute. I just want to go through all the other two, all these steps, and then we'll calculate them with the calculator. Okay, here's the second option. Still the same area, everything the same. I still have 0.5, 1, 1.5, and 2. But this time I want right 4. Okay. So base times height. So this is the rectangle now. Base times height. This is the rectangle now. Base, of course, times height, and this is the rectangle now. And base times height, and this is the rectangle now. So this is still 0.5 in front, but the height is here, f of 0.5 plus f of 1 plus f of 1.5 plus f of 2. What can you say about this area versus the exact area? Is it an underestimation or an overestimation?
Underestimation.
Of course, look at all this. I can't account for that. Under. Good. What about here? Under or over?
Over.
Of course, look at all these areas that are not even, why are they there, right? Over. In a moment, we'll plug in the calculator. Last one. But now I have to find the midpoint. This is still 0, this is 0.5, this is 1, 1.5, and this is 2. But now this is 0.25. The height, it hits the graph, and I draw a horizontal. This is the first rectangle. Height, it hits the graph, I draw a horizontal. And this is the next one. Height, hits the graph, draw a horizontal. That's the next. Height, hits the graph, horizontal. So this is 0.25, this is 0.75, this is 1.25, and this is 1.75. This time the area with m, mid 4 subintervals will be still 0.5 outside, base. So height, f of 0.25 plus f of 0.75 plus f of 1.25 plus f of 1.75. Question. Which of these three do you think is the closest to the true area under the graph? The first, the second, or the midpoint?
Midpoint.
The midpoint is the best. Depending on the graph. But this will be between these two. Right? Depending on the graph is because I cannot say that this will always be smaller and this will always be larger. Because if the function is decreasing, it's going to be the other way around. But this number that we are going to get here will definitely guaranteed be between these two. One of them will be bigger, the other one will be smaller. Okay, so now I will calculate with my calculator these numbers. So in y equals, please enter x squared and go to second and table and just punch in all these numbers. With a 0 there is nothing I can punch in. With 0.5, of course, is 0.25. With 1 is 1, and with 1.5, we know that is 1. I know the answer. With 1.5 is 1.25. But what am I trying to do here? Okay, 2.25. So the sum will be, so 2.25, this is 250, so this is 350. This is the area. Of course, it's an approximation, it's underestimated, and it only uses 4 subintervals, and that's the area. Okay, the other one. The 0.5, of course, is 0.25 with 1, with 2.25, and 2.4. So this is 250, 350, 750. Okay, the last one. Sorry, I forgot to multiply by 0.5. So 3.5 times 0.5, 1.75. So times 0.5. Don't forget to multiply by 0.5. I left it alone there and I forgot about it for a second. So this is multiplied by 0.5, so multiply by 0.5. So 7.5 times 0.5. That's the base. You cannot forget the base. So the first one was 1.75, the second one was 3.75, and now let's determine the last one. So I'm just going to do it as 0.25 squared plus 0.75 squared plus 1.25 squared plus 1.75 squared, and close the parenthesis, 2.625. As expected, right in between. Now I'm not saying in the middle or anything like that. Between 1.75 and 3.75, I get this, which is the best approximation. Best approximation. Okay, now bear with me. I'm going to ask you a question. What if, let me see where I'm with the video.